Hi everyone. In this video session, I would like to explain regarding bathtub curve. That is one of the topics in time-dependent probability evaluation. So this is the curve which represents the bathtub curve. Why the name the bathtub curve is if you draw a graph between a plot in between this failure rate and time, that is time on x-axis and failure rate is on y-axis. If you draw a graph in between these two, then you will get this plot, a graph which almost looks like bathtub. See here, that is the beginning at the position high, and in the middle it will be low and constant, and gradually it will go to the high position. Okay, then as such, as it is like a bathtub, then this curve is nothing but bathtub curve. So why to analyze this bathtub curve means this bathtub curve represents the failure rate, how this failure rate varies with respect to time. So finally it describes the failure rate of the system, of the component. A system may be any mechanical system, or a component may be any mechanical component, or electronic component, or mechanic or electronics component, and electrical component. So after manufacturing, every component must reach to the customer, right? So before it is released to the customer into the market, then a proper testing is must to avoid the failures, any problems in the component. So to represent that failure rate with respect to time, then we have this bathtub curve to analyze it. Okay, here in this bathtub curve, here if you see this, we have three different phases, phase 1, 2, 3. So now this phase 1 represents the debugging phase or debugging period, or also known as infant mortality period or mortality phase. Infant mortality phase. Second phase is the operating period. And third one is the wear out period. First, one by one we will see now. This first phase, that is debugging period. So this is the debugging period. Then where, see here, the failure rate is varying like this with respect to time. That means as time is increasing from 0 to its value, time is increasing, then here failure rate is starting from maximum, and gradually the number of failures are decreasing. After reaching to this position, see here the failures are almost constant, very low. Failure rates are very low and almost constant. So that is the second phase, that is nothing but operating phase from here to here. So afterwards the failure rate gradually increasing, see here, with respect to time, that is nothing but wear out period. wear out period. Okay, now we'll see what is the reason for this debugging period. Debugging period, first phase is the debugging period, that is the failures will occur, failures will be more, and they gradually decreasing with the repairs or any with any precautions, with any care if you take. So why these failures, these many failures will occur at the infant phase, at the beginning phase? Why we need to debug these failures? The main causes for these failures are any, for suppose any manufacturing errors, any manufacturing errors, any design errors, and then a poor quality, okay, any like installation problems, so these are the different failure reasons, failure causes that are there in the first phase. Then what action we need to take for this first phase to avoid these failures? So basically we will conduct burnout phase. For the burnout testing, we need to conduct, that is as a part of debugging. If any bug is there, we need to debug them. So if any early failures are there, then we can remove them, we can avoid them by using this burnout testing or debugging period, debugging analysis. And second phase, that is operating phase. Basically failures are low, almost constant. So then this period is nothing but operating or normal period. Operating or normal period. So even these low rate of failures, the main causes for this constant and low failures, low rate failures, the main reason is basically random failures due to unpredicted external events. What is that? Random failures due to unpredicted or unpredictable external events. Unpredictable external events. Okay. So to avoid that, what action you can take these even low failures? So preventive maintenance can help to extend this period. So before getting any failures, if you can have this preventive maintenance like cleaning to any mismatches or any operating errors, if you can avoid them by using this preventive maintenance, then you can extend this normal operating period. Okay, this is about first and second phase. Coming to the third phase, that is basically due to the aging of the components. Aging of the components, then this failure are nothing but aging failures also. This period. The main causes for these failures, because these failures will increase with the time periods, because at the end of the component, basically at the end life of the component or system will get these failures. The main causes are component wear and tear, okay, and then any like material fatigue, any corrosion, like any insulation breakdown, so these are the causes for getting these failures at the end life of the component. So to avoid that, the action should be taken. That action is just replacement of aging or old components before these old components reach to this phase. Then what happens if these old components, if they reach to this third phase, that is aging failure phase, then breakdown will occur. To avoid this breakdown, we need to replace these old components with new components. That is at the end of the life, at a certain period of time. Okay, this is regarding bathtub curve. Basically, this bathtub curve will be used to describe failure rates with respect to time. So that is whatever the diagram I have seen in this, that is for see here. I will show you the diagram. This diagram is for basically electrical and electronics components. Whereas if you consider mechanical components, then this bathtub curve shape will change. I will show you how it will be. That will be like this. Mechanical component. See here. What is the main difference here? Main difference is this operating region is not that much constant, and it's like in very sharp curve. Then operating time period is very low here, because these are for the this bathtub curve is for the mechanical components, where we have more frictional losses, where we have more wear and tear losses with these problems and external events, whatever it is. So with these problems, then this is the drawback here. Then where you have less operating period with short curve. So this is regarding bathtub curve. I hope this is clear to you. Thank you very much.